So now we're going to move on to the second way of solving linear systems, and that's using a method called substitution. Now in substitution, what you do is you take part of one of the equations and you plug it into the second equation. And I'll show you how that looks. So for these two equations, I have y is equal to 3x plus 2 and x plus 2y is equal to 11. And I'm trying to figure out what solution works for both of them. So what I'm going to do is I'm going to plug in this portion of the equation in for where y is here. It's easier to see. So what I'm going to do is I'm going to take the second equation, rewrite it out, so it'll be x plus 2 times, and now I'm going to take that value of y in the upper equation, 3x plus 2, and substitute it in where y's value is in the second equation. So that's equal to 11. So now I'm just going to simplify this whole thing. So use the distributive property. Combine terms. Subtract 4 from both sides. I end up with 7x is equal to 7. So x's value is going to be equal to 1. Now I plug that into either of the two equations, and I'm going to now solve for y. So I'm going to choose to plug it into this equation right here. So y is going to be equal to 3 times 1 plus 2, which is just going to be equal to 5. So my point that works as a solution of both of them, I think is going to be 1, 5. And I have to check that in the equation, the second equation here now. So I'm going to plug that into the equation I haven't plugged in x into. So I already dealt with that one. I know it's a solution for that one. Now I have to plug it into the second one. So does this work? Well, it does 1 for that x plus 2 times 5 for that y equal 11. Yes, it does, because 1 plus 10 equals 11. So that's a solution also. So I know that this here works for both. And so that's the solution to the system. Similar situation here. I've got x minus 2y is equal to negative 6, and 4x plus 6y is equal to 4. I have to do a little bit of rearranging, but I'm going to use this equation right here to set it up so that x is the variable all by itself on the left-hand side. How I'm going to do that is I'm going to add 2y to both sides. When I add 2y to both sides, I'm left with x is equal to 2y minus 6. So all I did was I added 2y to this side and I added 2y to this side. So now I've got this, what x's value is. I'm going to plug that in to the other equation. So I have 4 times 2y minus 6, because that's what x is equal to, plus 6y is equal to 4. When I do that using distributive property, it's going to be 8y minus 24 plus 6y is equal to 4. When I combine terms, I'm going to have 14y. When I add 24 to both sides, I'm going to end up with 28. So this is just solving equations the way we've done before. Divide both sides by 14, I get y is equal to 2. So I've got what y is now equal to, and I'm now going to plug that into this first equation. So x minus 2 times 2 is equal to negative 6. So x minus 4 is equal to negative 6. So x is going to be equal to negative 2. So what I'm thinking my answer is going to be negative 2, 2. I'm now going to plug that into the second equation here and see if that works. So 4 times negative 2, so that's what x's value is, plus 6 times 2, is that equal to 4? Well, it's going to be negative 8 plus 12 is equal to 4. That's true. So then I know that this is the correct answer for both of them. So for the system, that's the correct answer. So once again, this is all about isolating one of the variables and then plugging it into the other equation. Some of them are easier and some of them are harder. Like right now, this one here, it's already set up for y is equal to something. So I can immediately plug what's on this part here into where y is there. So I'm just going to rewrite this second equation as 3x plus 2x plus 5 is equal to 10. Combining terms, I end with 5x plus 5 is equal to 10. Subtract 5 from both sides, I end with 5x is equal to 5. So x is going to be equal to 1. Plug that into the first one up here. So it's going to be y is equal to 2 times 1 plus 5. So y should be equal to 7. The last step is key, really important. So plugging that in, it's going to be 3 times 1 plus 7. Is that equal to 10? Yes, it is, because 3 plus 7 is equal to 10. So my answer is going to be x is 1, y is 7. And you'll get better at these as you practice. So last one here, and again, in this case here, I have to rearrange one of these. It's always good to choose one where the variable is a single variable, a coefficient of 1. That's the case with this and this, because it gets complicated if you have to solve for that. There, you got to do more division. So what do I decide I want to work with? Do I want to work with x or do I want to work with y? Either way, I should come up with the same answer. So I'm going to rearrange this second equation. It's going to be now x is equal to negative y minus 3. So now I'm going to plug that in up here. 5 times negative y minus 3 plus 2y is equal to 9. This is going to be negative 5y minus 15 plus 2y is equal to 9. Negative 5y plus 2y is going to give me negative 3y minus 15 is equal to 9. Add 15 to both sides, I get negative 3y is equal to 24. So y is going to be equal to negative 8. Now I'm just going to plug that into either of the two equations. I'm choosing to plug it into this one here because it's a little bit easier to work with here. I'm going to plug it into here. So x plus negative 8 is equal to negative 3. Add 8 to both sides. With x is equal to 5. So my answer should be 5, negative 8. That should be my answer. I'm going to plug that into the first equation to check and see. So it's 5 times 5 plus 2 times negative 8. Is that equal to 9? Well, is 25 plus negative 16 equal to 9? Yes, it is. So then I've got my answer, and it's right there. Key idea, you've got to go ahead and substitute in and then check your answer as well in both of the equations.